Okay. So this is how the Verilog, the EDA playground looks like. You see login, so you have to make an account. Okay. It's nice to have an account because it will save all your design. Whenever you put a new design, it will save it to your account. So you have a list of all your designs. Okay. At the right corner, you put the Verilog code, the design. So I put the Verilog code of the traffic light. Okay. The same thing that I've just been explaining, I put it here. Okay. And on the left side, in the left block, you have the test bench. You write your test bench. So I have the initial, remember? I have the initial block, and I put in it the pattern of the inputs that I want to change, and I will monitor the output in, you would see here, the display. This one. This is the monitor. So the stimulus is input stimulus, as you can see, and I'm changing the input, and I'm monitoring the output. Okay, so here you see that there is test bench and design is using system Verilog and Verilog, and there are a lot of tools for the simulation. Choose any one. So for example, Riviera, this one. So it's a simulation tool for a special type of FPGA for Altera, but yeah, you choose a tool for the simulation. Okay. And this is the details. This is, you name your design for something so that later on you know what it's called and you put a description for it. Okay? And then you see run. If you press run, let's see here. Let's see. Run. Will it go to your account, right? Yeah, that's okay. Yeah, that's okay. Run. So after I pressed run, what do I see? Look, kernel, 0, x, and then you see like don't cares and don't care. This is the result of the display. You see the display in the code. So I'm displaying the reset, the car input output, the lights, and the state. What is the current state? And I'm seeing it in the values. Okay, so you can always test whether your design works as you want or not in the simulation. Okay, so the simulation print on the screen. You can see what it works, how it works. Another way to test if your design is working correctly or not is to examine the waveform. Here I printed. You can actually see the waveform. So EDA Playground allows you to do that if you make sure that you do this. Open EP wave after run. Okay, you click on this, it will open for you the EP wave. Inside it, you get the signals that you want to see. So I have my test FSM, which is the name of the test bench, and I say that I want to see the clock, the reset, the inputs, and the outputs, the lights, everything. So let's say append all. Okay? And you can see the wave actually. You can see when the clock change with the car east-west, which is the input, how the lights change, the output. And whenever reset happen, will the state change or not? Okay? So this is another way to see if your design is working correctly or not by looking at the wave itself. And you can always change the radix, whether you want to see the values on the wave as what, as hex or as binary. So you will see that the values here has changed to binary. You can view it as hex. Okay? And yeah, it's a nice tool to try it. So try the AND or invert when you go home and make sure that you go through this process. Okay? And any question? Okay. This tool actually also do the synthesis, but because we are synthesizing for special FPGA, so Paul was going to tell you how you're going to do the synthesis on the FPGA. So far what I have been explaining is what designing the Verilog test bench, how to test your Verilog before you go to the synthesis to the gates, how actually you're going to download your Verilog to the gates, and that's what Paul is going to show you. Any question? Okay, thank you.
How about we take a 5-minute break while Paul sets things up? I know this, listening to a language description can be pretty dry, but unfortunately there's just no other way around it. What Salma described is like 1/100th of what Verilog is, but you don't need kind of the full glory of Verilog for design assignments, so just bare minimum would work. So let's take a 5-minute break.